Okay, class 12. Here's one problem based on Kirchoff's laws. All right. So here, what I've taken is, here are two loops, as you can see. Okay, we have a 2-volt battery over here, because of which a current I1 is given out by this battery. Okay, so I1 is coming out from the battery. So we have a resistor R. Okay, and we have resistor R5, resistor R6, and we have resistors R2, R3, and we again have another battery over here, that of 3 volts. Okay, and we have R4 over here. Alright, so to say, we have two closed loops. Now what we need to do is, we need to apply Kirchoff's voltage law and Kirchoff's current law in both of these two loops. Okay, and the question is something like, if R1 is 1 ohm, R2 is 2 ohm, R3 is 3 ohms, R4 is 2 ohms, R5 is 1 ohm, R6 is 2 ohms, find I1 and I2. See, I1 is the current that is drawn out of the battery of 2 volts, and I2 is the current that is drawn out of the battery of 3 volts. And you can see from here that I2, alright, is coming in this direction. I2 is coming in this direction, I1 is coming here in the upward direction, I2 in the downward direction. So what happens is, at junction B, at point B, I1 and I2, they meet at junction B, and therefore they flow as I1 plus I2. So through resistor R5, we have current I1 plus I2 flowing. Actually, at this junction, what we have done is, we have applied Kirchoff's current law. Okay, I will show you how. Also at this junction E, I1 plus I2 was flowing through R5, through this arm, so to say. I1 plus I2 was flowing. They reached junction junction E. Okay, so what happens at junction E? They get distributed again as I1 and I2. Okay, so I2 flows in the upward direction and enters this battery. I1 flows in the downward direction and enters this battery of 2 volts. Okay, because remember, whatever current is drawn out of the battery, the same current has to enter the battery. The same value of current has to enter the battery, remember. Okay, that is exactly what we see in here also. I2 is being drawn out of battery of 3 volts. The same I2 is entering. Alright, so let me show you how this is current, Kirchoff's current law over here. Okay, so we see I1 and I2 flowing towards the junction, this junction B. So therefore we take I1, I2 to be positive. Alright, so therefore we have I1 plus I2. Alright, okay. Say for example, let's not take this to be I1 plus I2. Say for example, this is I3. The current flowing towards R5 is I3. So I3 is moving away from the junction. I1 and I2 are flowing towards the junction. I3 is moving away from the junction. So therefore, I will take I3 to be negative. So Kirchoff's current law tells us that the algebraic sum of the currents flowing into the junction or meeting at the junction is 0. So we have 3 currents, 2 flowing into the junction, 1 I3 flowing away from the junction. So this is equal to 0. So from here, what do we get? I3 is I1 plus I2. This is what we get. Okay, so therefore instead of I3 we have written I1 plus I2. Okay, the same applies over here. I1 plus I2 is flowing, or I3, take it to be I3 here also. I3 is flowing into the junction, so take I3 to be positive. I3 is positive, whereas I1 and I2 are moving away from the junction. Okay, so minus I1 moving away from the junction minus I2 moving away from the junction is equal to 0. This is at junction E, remember. Okay, so what do we get again? I3 is I1 plus I2. So this I3 is again I1 plus I2. So that is why we've taken this to be I1 plus I2, remember. Okay, it's kind of intuitive also. I1 plus I2, they meet at the junction and they flow as I1 plus I2. Okay, I1 and I2 flowing towards B and this together flowing as I1 plus I2. Okay, same, I1 plus I2 flowing here, they branch themselves out as I1 and I2 respectively. Okay, but actually what I only wanted to tell you is, actually at point B and point E, when currents meet and when currents divide, they are actually obeying Kirchoff's current law. Okay, now see, let us apply now Kirchoff's voltage law. See, applying KVL, Kirchoff's voltage law, in loop ABEFA, meaning the lower loop. Okay, so what we get is, see, now in order to apply Kirchoff's voltage law, we first of all, don't forget, we first of all need to choose a direction of movement, either clockwise or anti-clockwise. Okay, so here I have taken again to be a clockwise direction of movement. I will show you in the other example, when we take anti-clockwise direction of movement. Okay, so we choose clockwise direction of movement. So when we choose clockwise direction of movement, we first of all encounter this register R1. So we're moving in the upward direction. Get used to this, okay, and understand this very, very clearly. So when we are moving in the upward direction, since we've taken it to be clockwise, we see current is also flowing in the same direction, which means we are moving from higher potential to lower potential, because current always flows from a higher potential to lower potential. Okay, so we are moving in a direction of higher to lower potential. So potential is decreasing. So potential is decreasing across this resistor. So therefore we take it to be minus I1 R1. Potential difference across this is minus I1 R1. Okay, then after we encounter R5. Okay, so across R5, the potential difference will be, since current I1 plus I2 is flowing through it, the potential difference across R5, so we have taken clockwise direction of movement, current I1 plus I2 is also flowing in the same direction, so here also we are moving from higher potential to lower potential. So therefore potential difference across R5 is also minus I1 plus I2 into R5, negative potential. Then we encounter R6. So our direction of movement is clockwise, so therefore we are again moving from higher potential to lower potential. So potential difference across R6 is minus I1 R6. Okay, minus I1 R6 plus 2. Why plus 2? Because we've taken clockwise direction of movement. Okay, so here therefore we are moving from negative plate to the positive plate. Okay, so therefore there is a rise in potential since you are moving from negative plate to positive plate, so therefore plus 2 over here. So this is the algebraic sum of the potential difference in the closed lower loop. So therefore this has to be equal to 0 according to Kirchoff's voltage law. Okay, then after, in this numerical, since the values of R1, R5, R6 are given, so I've written substituting the values of the resistances we get. Since R1 is 1, so therefore minus I1. R5 is also 1, as you can see here, R5 is also 1, so therefore minus I1 plus I2 from here. Okay, then R6 is 2 ohms, so therefore minus 2 I1 plus 2 is equal to 0. Then after simply rearranging, okay, adding the like terms, okay, I1, so this is minus 4 I1, then minus into plus is minus I2, plus 2 is 0, then simply rearranging, 4 I1 plus I2 is 2. This is my equation number 1, which we get from the lower loop. Okay, get this thing very, very clearly, class 12. Okay, any problem you have, you let me know. Okay, you have to let me know, but I don't see any of you, coming up with any problems. Okay, you can let me know in WhatsApp itself, or you can write a comment down below the video itself. Okay, then after applying KVL in loop BCDEB, which means the upper loop. So we are applying KVL in the upper loop. All right, so here also I've taken clockwise direction of movement. Let me show you anti-clockwise direction of movement. What's there? Okay, say for example I choose anti-clockwise direction of movement. Okay, but let me write the equation, just a sec. All right, so anti-clockwise direction of movement, I'll write the equation itself over here. Okay, so let us first come across this resistor R4. So we've taken anti-clockwise direction of movement. Now we see that we are flowing in the same direction. We are moving in the same direction as the current I2. So here also we are moving from higher to lower potential. So potential difference across this R4 will be minus I2 R4. Then after we come across this battery, again we are moving from negative plate to positive plate. So this is plus 3. So lower potential to higher potential is positive, so plus 3. Then we come across R3. Again, we see that current is also flowing in the same direction. So we are moving from, since I've taken anti-clockwise, so we're moving from higher to lower potential. So this is minus I2 R3. Mind you, current flowing across R3 is I2. The same story in case of R2. We are moving in the direction of current. So this is minus I2 R4. Then across R5, since we've taken anti-clockwise, we are moving in the same direction as the current. So this is also minus I1 plus I2 inside the bracket R5. This is the algebraic sum in the upper loop. This has to be equal to 0. So this is the equation. Minus I2 R4 plus 3 minus I2 R3 minus I2 R4 minus I1 plus I2 into R5 is 0. Okay, actually what I had done, okay, beforehand what I had done is I had taken clockwise direction of movement. Okay, and I had landed up at this equation. Okay, this equation, all right, and the equation that I just derived are one and the same thing. Okay, you can try doing this yourself, class 12. Okay, and any problems you have to learn how to do this, because we are going to need this. We'll need this in a lot of other things as well, and you might get numericals based on this. Okay, so you have to be you have to know how to find equations like this, how to apply Kirchoff's voltage law, so to say. All right, so get used to this, practice this. You need to practice this, class 12. Another problem I have here. Okay, in one I had taken anti-clockwise, in another one I had taken clockwise. Okay, very quickly let me show you. Applying KVL in the lower loop. Okay, that is ABEFA. So I have taken 3 resistors, and by the way, in this picture we only have one source of current over here. So from E, current I is drawn. It flows through R1 and reaches point B. At point B, what happens is, since we don't have any other extra source of current, so at point B the current branches itself out. So I branches itself out into I1. Say for example I1 flows in the upward direction, so the current that is flowing through the arm, this arm BE, is I minus I1. I was the initial current, so I1 flows in the upward direction, so I minus I1. This is also Kirchoff's current law, remember. So at junction E, I1 flows in the upper arm, and I1 finally approaches point E. Okay, so I1 plus I minus I1 will again be I. Okay, so the same current that comes out of the junction I enters the battery. The same current that comes out of the battery enters the battery. All right, so that's the story. And applying Kirchoff's voltage law in the lower loop, we've taken anti-clockwise direction over here now. We've taken anti-clockwise. So first we encounter R4. So we are moving in this direction, and we see current is flowing in the opposite direction. So to say, we are now moving from lower potential to higher potential. Our direction of movement is from the lower potential to the higher potential. So whenever we move from lower potential to higher potential, we take the potential difference to be positive, remember. So therefore, the potential difference across R4, through which this amount of current is flowing, is positive. So therefore it is I minus I1 into R4, positive. So I minus I1 into R4, positive. Then after we come across R1, we again see, since our movement is in the anti-clockwise sense, so therefore we again are moving in a direction opposite to the current itself. So we are again moving, so to say, from lower potential to higher potential. So lower to higher potential, so therefore potential difference across R1 is positive. Then after we come across this cell, okay, so we are moving in anti-clockwise, which means we are moving from positive plate to negative plate. So therefore potential difference across the cell is negative, minus E, since we are moving from higher potential to lower potential. So it is minus E. So this is the algebraic sum in the lower loop. So this is equal to 0. All right. Same way here in the upper loop, I have taken clockwise sense. So first of all, I encounter R2. All right, I encounter R2. I'm moving in this direction same as that of the current. So I'm moving from higher potential to lower potential. So this is minus I1 R2, minus I1 R2. Then I encounter R3. Okay, I'm moving in this direction, same as the current. So this is minus I1 R3. Then after I encounter R4. We encounter R4 in both the loops. R4 is common to both the loops, remember. So you need to consider R4 in both of the cases, both the loops, in case of both the loops. So we are moving in the clockwise sense. So when we come across R4, we are moving in a direction opposite to that of the current. We are moving in a direction opposite to that of the current. So therefore, the potential difference across R4 will be positive, since we're moving from lower potential to higher potential. This is plus I minus I1 into R4. Okay, this is equal to 0. This is the algebraic sum in the upper loop. See, minus I1 R2 minus I1 R2 minus I1 R3 plus I minus I1 R4 is equal to 0. I had landed up at the same equation C over here. Okay, beforehand, things that I had done. Okay, so see, this is the equation. This is the equation that we get from the first loop, from the lower loop. Okay, then substituting the values of R1, which are given over here. These are just random values that I had given. Okay, this is my own question. So substituting these values in this equation, I get this. Rearranging, I get this. Okay, then applying KVL in the upper loop, I get this. Then again, substituting the values of R2, R3, R4, I get this. Rearranging, I get this equation. Alright, so the question will be like, find the value of I and I1. Okay, it could simply be find the value of I. So solving these two equations, you'll get the value of I, the current flowing. Okay, likewise, in the previous question, in this question, where we had two sources. Okay, in both of these equations, in both of these loops, okay, we get this equation, okay, substituting the values, we'll end up at equation number 1. Likewise, you'll derive equation for the upper loop, which is this, in this case. Okay, then after substituting the values and rearranging, you get this equation. Solve equations 1 and 2. Okay, then after you'll get the value of I1 and I2. Okay, that is exactly what the question is asking. Find the values of I1 and I2. This is in the first question. This is in the second question. Okay, these are the values, as you can see. Okay, now what I want to tell you, class 12, is these are only two random examples that I've given. These are my own questions. You get a lot of variety in Kirchoff's laws. Okay, you get a lot of numericals, other kind of numericals. So you should be an expert in applying KVL and Kirchoff's current law. Kirchoff's voltage law is more important, okay, because you need to apply Kirchoff's voltage law for different loops. Alright, Kirchoff's voltage law is what is going to give you the equations. Alright, so you need to be very good at doing this. So I suggest you to stick to that convention, remember. First of all, what you should remember is, you should choose a direction of movement, either clockwise or anti-clockwise, whichever you want to choose, whichever direction of movement you want to choose in the very same loop, it's up to you. Okay, then after, don't forget, this is what is more important. Potential difference decreases, you take the potential difference to be negative. Potential difference increases, you're moving from lower potential to higher potential, so to say, you take the potential difference to be positive. Okay, so I don't want to make a lengthy video. It'll be very difficult for me to upload the video then. Okay, so I stop here. All right, practice this thing well. You don't understand, let me know. Okay, write in the comment section, or you can write in the WhatsApp group itself. Okay, all right, I will make another video for you if you don't understand this particular topic. All right, so practice this. Thank you.